Welcome to all. Today I am going to talk about an interesting topic related to tropical stratosphere. The topic name is Quasi-Biennial oscillation. You will understand the title. So we go on from the back. See the oscillation. What do you mean by oscillation? You all know about oscillation. Oscillation, it is a movement back and forth in a regular rhythm. For example, if you see this pendulum, how it is moving. It's moving a right side and left side, a right side and left side. It's called oscillation. Coming to the word biannual, this biannual indicates the period of the oscillation. What do you mean by biannual? It means it takes place at alternate years. That means something like 24 months periodicity. You know the periodicity. Here the quasi indicates that the oscillation is not exactly 24 months, it is around 24 months. So this indicates the quasi-biennial oscillation. Okay, why it is important? Where we could see this oscillation? This oscillatory behavior is evident in tropical zonal winds at stratospheric levels, means above 10 MB pressure level. How we can say it's oscillation? If you see the zonal wind direction, we have eastward and westward. So the stratospheric zonal winds have a rhythm. Some months it's going to be eastward, and after some months it will be in westward direction, and vice versa. But coming to the periodicity, it is not exactly the 24 months periodicity. It is it varying periodicity from 23 to 36 months with a peak period about 27 months. So coming to the QBO, we mentioned here the QBO, general term we used. If you want to be more specific, we have to say it as a stratospheric quasi-biennial oscillation or a stratospheric QBO. Before we learn about the QBO, I would like to emphasize on the stratospheric observations. The attention on the stratospheric winds was started in 1883 due to a great eruption in Karakatu. The Karakatu volcano, situated in between Sumatra Island and Java Islands in Indonesia. It's in a great eruption, volcanic eruption. Due to this great eruption, a strong dust cloud has been ejected into stratospheric levels. At the time, the dust cloud was propagating in easterlies, that means in the westward direction. And then people thought that the stratospheric winds always goes into westward direction or easterlies. Later in 1909, over Central Africa, Professor Bergson done some radio sound measurements. He found the winds are showing a westerlies, that means in the eastward direction. And he proposed that lower stratospheric wind are westerly direction. Later it has been named as Bergson westerlies. 1883, the stratospheric upward winds are shown easterlies, whereas in 1909 the lower stratospheric wind shown westerlies. So after that, based on these measurements, people thought that lower atmosphere always the winds will be in westerly direction, which is named as a Bergson westerlies, and then the assumption was the upper stratosphere the winds will be in easterlies. It's also named as Karakatu easterly. In 1961, Professor Reed made a breakthrough using radio sound measurements. That measurements given a clear-cut idea about the stratospheric winds especially in the tropical latitudes. Paper by Reed et al. The left side figure shows the paper published in 1961. On right side, you can see the famous figure from that paper. If you come to this figure, what this figure shows is zonal wind contours plotted time versus height over Kantun highlands. Clearly, the shaded areas here indicates the westerlies. The white contour shows easterlies. If you notice at any particular height, the periodicity looks like a 24 periodicity varies a kind of a 24 month. This indicates there is a kind of a long period oscillations that exist in the stratospheric region. However, the QBO name was not yet introduced by that time when the Reid introduced these observations to the scientific community. With an extended observations in late 1960s, it is clear that the periodicity is not a fixed to 24 months. Later, somewhere in 1965, the QBO name has been coined. After that, everyone using the name Quasi-Biennial. The figure shows the extended view of the stratospheric wind systems. The figure is taken from Free Berlin University. It is a kind of a representative, the wind system representative for the QBO winds. If you see the data, these contours available from 1953. So here these are not from one location. These are compiled from 3 different locations. For example, the measurements available Canton Islands are used since in 1953 to till August 67. Later on, Maldives Islands data used till December 75, and after that Singapore observations are available, which are continuous measurements. Those are even used to compile these stratospheric wind systems. And here the picture shows you zonal wind contours. The right side axis shows the height. This is the height, and here it shows the left side shows the pressure in hectopascals. Here the winds, the contours having the shaded contours, this indicates the westerlies. The white region indicates the easterlies. The contours here is with a 10 meter per second contours are there. So if you go to the closer look of this figure, you could see plenty of the features, QBO features that we could say QBO properties we can highlight here. For example, if you see the wind systems, which shows a downward phase propagation with the time. Okay, and another thing is these are alternative. This once we get the easterlies, and then we get a easterlies, westerlies, easterlies, westerlies, easterlies, westerlies. It's a kind of a alternating that indicates the, and if you see, notice the alternatively they are continuously propagating downward. It indicates the behavior of the stratospheric winds, which is completely contradicting to the earlier observation. So now the stratospheric QBO wind system indicates the QBO is not a fixed one. The wind system is not a fixed at any altitude. This wind system is highly varying. If you notice from this closer look, we can say that there is an alternating easterly and westerly wind regimes which are propagating downward direction. Then if you see the surge completely to the individual, westerlies are moving faster than the easterlies. There is a transition that takes place between that means eastward to westward, that takes place at 30 to 50 hectopascal. There is a slight delay, and if you notice that magnitude of these wind systems, the easterlies are very strong, which is in the order of 30 to maximum within 30 to 35 meter per second, whereas the westerlies are weaker, which are in the order of 10 to 15 or maybe 10 to 20 meter per second. The maximum amplitudes, if you want to see where is the maximum amplitude and phase is appearing, that is noticed somewhere in the at 20 hectopascal. At the 20 hectopascal you could see very strong amplitudes. It is true for both easterly as well as easterly phase or westerly phase. Both phases it shows similarly. And if you want to see the periodicity, how are you going to define the periodicity? Okay, let me wipe these things so that it will be clear for you. Okay, how are we going to define a periodicity? Let's take one cycle. Let's take at 30 hectopascal. Let's assume from this point, this is westerly and this is easterly. Up to this, again the westerly starts here. So how we can define this periodicity is, here the wind system is like this: the positive wind till up to this, and then negative wind here. So this is a kind of a one cycle. So the periodicity is counted as from this point to this point, the time taken from this position to this position. Okay, this is known as the periodicity. When the Reed proposed, the periodicity was noticed somewhere in the 24 months, but based on the large data sets, when you compare with large data set, we could notice that the periodicity is highly varying, which varies from 23 months to 36 months with an average about 27 months. And if you notice the cycle to cycle, the amplitude and phase is varying. It is not uniform. One cycle to another cycle, the amplitudes as well as both phase both are varying. Here I listed all the properties of those what we discussed in the earlier slide. That one is alternating easterly and westerly wind regimes which are propagating downward with time. Second important thing is the westerlies moves faster than the easterlies, and the transition to easterlies is often delayed between 30 to 50 hectopascal, and the easterlies are generally stronger, which are in the order of 30 to 35 meter per second, and whereas the westerlies only within the order of 15 to 20 meter per second. The maximum amplitudes of both phases typically occur near 20 hectopascal. And then if you go to the periodicity is, as I mentioned, the periodicity is highly variable, which varies from 23 months to 36 months. That means sometimes some years it will, some 2 years to 3 years. That is the reason the name has been given as a quasi biennial oscillation. If you take an average of the periodicity, which is in the order of 27 months. And again, you have to notice the important point is both period and the amplitude of each and every cycle is unique. It varies cycle to cycle. There is no commonality in between these amplitudes and periodicities. Okay, the only commonality what we noticed here is the downward phase propagation alternating easterly and westerlies. However, recently, somewhere in 2015, I want to highlight here, somewhere here, this alternating behavior has been disturbed. The disruption of this alternating easterly and westerly, it's a kind of a special behavior which is noticed in somewhere in 2015 to 2016. So we will discuss that later when we talk about the source mechanism that comes wind that is responsible for these wind systems. Okay, so far we learned about the historical view of the stratospheric winds, and then the Kibivo, and and then QBO compilation, wind compilation from the Free Berlin universities, and then we also learned about the important properties of the stratospheric QBO. Okay, what is this? If you question yourself, what is the source of these oscillations? What is the source of the oscillation and why it is important for us? Okay, it is a kind of a big topic. Actually, I wanted to wind up here, but I would like to give a glimpse about the source mechanisms, why these are important. Okay, coming to the source mechanisms, the eastward winds and westward winds, these are controlled by the dynamical forcing from the lower atmosphere. The eastward winds are the eastward momentum comes from the Kelvin waves, which are originated in the lower atmosphere, and they propagate into the stratosphere. In the stratospheric level, they deposit their momentum and provides the eastward wind systems. The same way, if you go to the westward winds, the westward winds are mainly produced by the momentum called mixed Rossby gravity waves. These are westward propagating waves. They depositing momentum in the stratospheric levels, producing the westward wind systems. So see, the eastward winds are given by the Kelvin waves. The westward winds are given by the mixed Rossby gravity waves. Another important factor that we have to remember, the phase propagation, which is mostly controlled by the gravity waves, which produce the momentum for both eastward and westward. However, the gravity waves are very important for the downward phase propagation of the QBO. Okay, coming to what is the importance of the QBO? As QBO impacts different layers of the atmosphere, the impact varies both latitudinally as well as in vertical direction also. It is influenced the stratospheric sudden warmings which occurs in the polar latitudes. It also, that is through latitudinal coupling. There is a controlling mechanism we will discuss in the later sections. And then if you go to the vertical coupling, it controls the upward propagation of the gravity waves and Rossby waves and Kelvin waves, which creates alternating wind systems in the mesospheric region. So it also has impact on the mesospheric semiannual oscillation as well. Okay, and then importantly for us, the QBO also influence the lower atmosphere, so called a tropospheric biennial oscillation. There was some linkage between the stratospheric quasi-biennial oscillation versus the Indian monsoon. During some phases of the QBO, the Indian monsoon is good monsoon. In the other phases, the Indian monsoon is in break phase. That's why it's got a lot of attention about the QBO. So, okay, don't worry about details. We will discuss in later classes. Until that, thank you and bye. Take care.